Okay, so we're going to look at how to get exact values for square roots and values involving pi out of our calculators. Now, if you have a calculator like a TI-89 that does symbolic manipulation, then you don't need these tricks. But if you have a standard calculator, even TI-84, they have functions where you can input values of pi, but they don't have functions where you can output values of pi. And so some of these tricks can be useful for, again, getting those exact values without necessarily having to memorize, for instance, the decimal equivalent of the square root of 3/2, for instance. So instead, what we're going to do is we are going to use some calculator manipulation in order to obtain those kinds of values. Now, some of these tricks are going to require you to have a good idea of what decimals look like in fraction form. If you don't have a convert to fraction button, we can use some things like the 1/x key for certain kinds of functions. But if you have a convert to fraction key, it won't work when there's a square root involved or a pi involved, but it will work if you can eliminate those components. And so those will be useful tools, and we will have to work around them because this particular calculator that's included in the computer in your standard apps, they don't have those kinds of features. But let's look at the sine of pi/3. Now, the first thing to keep in mind when you're working with trig functions involving pi is you need to be in radian mode. Now, this calculator on the computer it's built into Windows is a little funky in that you need to put the angle in and then take the sine of it. So pi divided by 3, and then take the sine of that value. And so what you get is 0.8666. Now, I've seen this often enough that I know that this is the square root of 3/2. But how could we do that? How can we establish that if we don't know that that's the case? Well, the thing to keep in mind here is that that number involves a square root. So one thing that we can do is we can square this value. And now when you square this value, what you get is a nice decimal. It's 3/4 when you square it. Well, if you write down 3/4 and you take this, because we squared it to get this nice number, you have to undo that squaring process to get the original number back. Take the square root of 3, you get square root of 3. Take the square root of 4, you get 2, square root of 3/2. So if you, for some of these numbers, like if you do pi divided by 3, and then you take the cosine, some of these are already going to be nice numbers. We already know that 0.5 is 1/2, hopefully. If you're not sure, you can take the reciprocal. 1 divided by 2, the reciprocal of that should be 2/1. So you can do that for if you think it's like a 1/3 or something like that. And we will actually use that somewhat later. Now, if it's 1/2, for instance, so let's say our pi divided by 4, and then we take either our sine or our cosine, we get this. And again, you can memorize this decimal expression. You see it frequently enough just to know this is 1/2. But again, the way that you can get out of that square root for your convert to fraction key is to square it. And then remember, this is the squared version. So you take the square root, this is 1/2, right? Take the square root of 1, you get 1. Take the square root of 2, you get square root of 2. So that gets you your 1/2. Now, for the inverse trig functions, you're actually going to get multiples of pi if you put in nice values like 1/2 or 1/2 or square root of 3/2. But how do you remember whether that's pi/6 or pi/2 or pi/4? Well, obviously, you can memorize those decimal equivalents, but there's another way especially if you end up with something that's actually not pi over 3 or pi over 6 or pi over 4, but maybe pi over 8 or something like that, or pi over 5, because you were given particular values. So the way to do this, we're going to do our 1 divided by the square root of 2. No, that wasn't what I wanted to do. Let's try this again. There's our square root of 2, and then 1 over the square root of 2 is our reciprocal. And then I want to take the inverse sign. Again, every calculator is a little bit different. And so the exact sequence that you have to use in order to enter these things may be differ from problem to problem. But you end up with something like this, 0.78. Now, what the hell is that relative to pi? Well, here's the trick. Divide this result by pi, and you get 0.25. 0.25 is 1/4. So that means you know that your answer is pi over 4 because it's 1/4 pi. So let's try the -1/2. So 1 divided by 2. Sorry about the lawnmower. Flip the sign. And then we do our inverse cosine. And we get this. What is that? Well, let's divide it by pi. And you get 0.666666, which is 2/3. So your answer is 2/3 pi, or 2 pi over 3. So that, again, you can use, if you have a convert to fraction key, you can use it, or you can just remember some of these standard decimal equivalents. There's only a limited number of them. So, but see, that's the trick. So when you're doing inverse trig functions for standard angles, you know that your answers are going to come out in terms of a multiple of pi. And so you simply divide out the pi, and what you get is a nice fraction that you can use to then convert and figure out what that multiple of pi has to be. But if you get, sort of weird answers, like you're putting in something that's non-standard, you divide out the pi and then you try to convert to fraction, it's not going to do anything, which tells you that it's not just a nice multiple of pi. It's not pi over 4, or pi over 6, or pi over 8, or whatever. It's something weird, and it's not convertible in terms of pi.